Good morning all. Welcome to this Town Hall 2024 Town Hall. I'm Mark Boden, Manufacturing Operations Director for Propulsion, and I'm very happy to be here with you today for this special event. We met just 1 year ago, and you can remember that time it was in the Mod 1 Assembly Hall, which is now called the EV Hall, because it's already full of new lines for electric motors, electric drive units, and battery packs. So it went so fast. That day, 1 year ago, it was just about announcing the journey for electrification for JLR and for the EPMC, and already today, we are almost there, almost. So this is one of the reasons why we are here today in this building, which is so special to us as well. This is the house of the famous i6, the engine all our customers want. And it's going to be also the house of the new V8 engine, the NC111. And we are so proud of that one as well. And I think this is a very good illustration of what the energy transition is. You know, it's not a switch. We are not switching to electric product in just a blink of an eye, but it's about transformation. It's a long transformation, and we'll keep manufacturing ICE engines for quite a long time as well. And in this transition, I have to say that we are also helped by some friends. We are helped by CJLR, who will help to manufacture some machine crankshafts, blocks, heads, etc. Will be helped also by India, the EPMC India, that will produce some ICE engines. And these are also enablers for the transformation, the huge transformation of the EPMC. So today is about people love and customer love. People love first. I have to say I'm so glad to work for a company that cares so much about people, that gives us such a time for us to stop manufacturing, to stop production, in order to have enough time to educate ourselves about the new products we'll soon produce here at the EPMC. And this is customer love, because to deliver the best possible experience to our customers, to deliver this modern luxury experience, we also need to understand what are these products, what is an EDU, what is a battery pack, how do they work, what are they made of, why is they so special, why are they going to beat the competition? And we need to understand also about the market. I'm very happy to have today experts that will explain this to us. Thank you very much. And before to leave the floor to Matt Large, our launch manager, I would like to wish you an excellent town hall today and to enjoy each and every minute. Thank you very much.
Right. Good morning, everybody. So I'm Matt Large. I'm one of the plant launch managers here at the EPMC. So this morning, just going to give a brief update against the site in terms of where we are as part of our EV transformation. So, as Mark mentioned, we've already started that journey, and really it was circa 12 months ago when we held the last town hall in what was then the old D4 assembly build area, and again, as Mark's alluded to now, referred to as EV, or EV1, as a build hall. So, in just under 12 months, we've seen significant transformation take place within that area and across other areas of the site as well. June last year saw the installation of the first pieces of equipment on the EDU assembly line. Some of the reuse equipment from what was in this area as the old J190 assembly, EDU assembly facility. Where we are today, we've got a fully installed transport system in the EDU assembly area. We're around 95% complete on the manual installations, and we're over 50% complete on the automated facilities, with the remaining pieces of equipment going through commissioning and witness at vendors over the coming weeks. Post-Christmas, the vacant space that was up in the Module 1A area has now laid home to the rotor assembly facility, and in such a short space of time, we're now nearing, or just over the 90% complete of installation, and the team's working through commissioning activities up in that area. Our EDU housing line, which is in the Mod 4 machine hall, they're now fully installed. Equipment is in, and the team are working through their 30-part capability runs ahead of our launch activities in the coming weeks. And then, very similar to the rotor line, the EDU stator line, which is within the EV1 build hall, pre-Christmas was a blank footprint. Now, where we see it today, we've got a circa 85% complete installation, and as a real key milestone for the team, in the recent weeks have produced the very first hairpins, which are a fundamental aspect, as we'll touch on later on, of the overall EDU assembly. So the video in the background that's playing, you can see that the battery teams are progressing at very similar impressive rates and not being left behind. Up in the top right-hand corner, just out of view, we've now got a fully installed frame assembly line. The team have already started progressing the first off parts through that facility, and there's a number on display at the end of the area. The pack installation, which is the video on screen as a time lapse, and as you can see, the teams aren't hanging around, they're progressing, they're getting the equipment in. This is the Zone 1 leg of the build, with the teams out in Grob, supported by plant teams from CME, maintenance, ops, over the coming weeks to finish off the final pieces of commissioning on certain pieces of equipment. And then what we can't see on the video on screen is we've also got the stack line mezzanine infrastructure is now nearing completion, ready for the first pieces of equipment to be shipped towards the back end of this month. And then we've got the area up sort of towards the middle of the screen that's been cleared out and made way for the BEM assembly, which will be starting to be installed in the beginning of May time. So, some really fantastic work that's ongoing and being delivered by all of the teams. And really, it's being supported by equally significant works across other areas of the site as well. So, we've got across our logistics and marketplace areas, significant changes taking place. Our laboratories and audit rooms are going through significant change, as well as our offline audit and test areas equally undergoing significant works to make this happen. And one thing that I just wanted to sort of call out and really identify, and not directly linked to the EV, but the fantastic work that you see behind us as part of the NC11 installations that the team have undertaken, again, in such a short amount of time, to the point where they are now and actually working through their launch builds. It's really important, alongside some of the fantastic work that we're seeing from a facility installation perspective, that we recognise the really good work that the teams are doing locally to prepare themselves for the challenges ahead. We've had key recruitment already start to take place across the operational teams, across the quality teams, across the maintenance teams, with a good number of those team members now firmly embedded in some of our prototype facilities, working in unity with colleagues across the business to build that product familiarisation, that early learning that's going to be really key to the success of some of what we've got to deliver in the coming weeks and months. And then in collaboration with some of our technical vendors and our technical partners, the teams have already delivered in the region of 650 days worth of training, which equates to nearly 5,000 or just over the 5,000 hours worth of training. And it's really, really important that all of this is about supporting our ability to deliver some of these exciting new products that we're going to touch on very, very shortly. So with that, it is a very brief update on where we are. What I would like to do is invite to stage Mr. Stuart Haitley, Joanne Pearson, Stefan Fuchs, and Parmjeet Plahey, that are going to take us through now some more of the detail around these exciting products. So please welcome to stage.
Thanks, Matt. So just like to introduce myself for those that don't know me. So as Matt said, I'm Stuart Haitley. So I'm the Senior Launch Manager here for Propulsion, both BAC and EPMC, and also Plant Transformation Lead as well. Just wow, really. To be honest with you, I'm going off script a little bit. Everything that Matt said so far, it is exciting, yeah. But it is a kind of recognition of all of the faces that I'm looking at the moment. Yeah, it's full commitment from the board to everyone in this room. So if you're building the fantastic engines in the machine hall, everything you're doing is playing a part of this, and it's absolutely incredible. So well done, everyone. So if we move on a little bit, please. The agenda today, sorry, Hester, there's one mistake. So first of all, we're going to talk to customer insights, and I'm going to welcome Joe to the stage. And then Stefan is going to talk through EDU. I may have to hold Stefan back a little bit because he's very passionate, which is absolutely fantastic to see on the EDU. And Parmjeet is going to take through our batteries. For me, a battery is what's in our hand controllers at home, but I'm led to believe that there's a lot more that goes into our batteries for EV. And then I'm going to talk about what's next. So it's really important that we're not just looking for today and tomorrow, but as a team, we're looking forward for the next 5-10 years. And making certain that we've got a legacy for us all to be proud of. So with that, morning, Joe.
Morning, everyone. Delighted to be here. First visit to this plant, so thanks for having me. So I am our Global Customer Insight Director. The job of myself and my team is to bring the voice of our customers into our company. We do that on everything we can possibly find the resource and the budget to do. So informing how our brands are perceived around the world, how our customer experience is being delivered, and we inform all of our products from their initiation some 6 years out from coming to market all the way through their life cycle. So making sure at every stage possible that we can bring the insight from our customers in. So that's my job.
Okay, thank you, Joe. And Stefan, introduce yourself.
Yeah, hi, good morning. My name is Stefan Fuchs. I'm the Chief Engineer for the electric drive units. And my job is to keep the competition at bay, get our cost for what we buy in for our assembly here under control, and make sure that we have a lot of fun doing all of that. Nice to meet you all.
Thanks, Stefan. And lastly, Parmjeet.
Yes, morning, everyone. So my name is Parmjeet Plahey. So I'm the Senior Manager for Battery Design. And interestingly, the first time I came to EMC, as it was when we were engineering the AJ200 diesel engine. So it's absolutely fantastic to see the transition to electrification whilst keeping the internal combustion engines live as well. So that's absolutely phenomenal. And my job is to work with the design and engineering and supplier teams to engineer the next generation of our BEV batteries. Really pleased to be here.
Okay, thanks, Parmjeet. Okay, I feel like Magnus Magnuson now, so we're going to get straight into it if we can now, Joe. So, Joe, what are the key legislative changes driving our move to EV?
Sure. So if I just walk you back a few years when, as a company, we developed our Reimagine strategy, we take into account lots of inputs to that, be they political, economic, sociological changes, technological changes, what our competition are doing. But one of the key feeds is also legislation, and this is so pertinent for our electrification strategy. So what we see coming at the moment is by 2035, there will be a ban on internal combustion engines in a number of our key markets around the world. So here in the UK, in Europe, in Canada, in some states of the US, so starting with California, but a number of other states in the US, will all ban internal combustion engines at that point. So we're 11 years out from that. Clearly, with a gestation period for our vehicles, we had to plan ahead. What we'll also see at that point is we'll see many markets around the world also setting targets for CO2 and also for fuel economy. So in particular, if we think about the UK and the US, where we will see those come into play, there will be minimum requirements for the durability of batteries. So, for example, in the UK, the batteries have to last for 8 years. They have to be able to do 100,000 miles in order to comply. There will also be minimum range requirements for vehicles produced. So in the UK, as an example, it will be 100 miles. Hopefully, my colleagues here today will tell us that we'll by far exceed those. But all of this legislation is political. So what we have to do as a business is work with the politics of the day, with lots of forecasts, lots of our strategy teams trying to, if you like, foresee the future. As you know, we've got elections coming up in the UK, there are elections coming up in the US, so we're constantly monitoring to make sure that our plans are in step with where we see the legislation change.
Okay, well, thank you. And how quickly do you think the transition from ICE to BEV is actually going to happen?
Yeah, it is dependent on different markets around the world. So right now we see quite dramatic adoption of battery electric vehicles in China. One of the main causes for that is the Chinese government are subsidizing Chinese manufacturers to make battery electric vehicles, so they're going very fast. They're producing them pretty cheaply because they're subsidized, so not in our part of the market, particularly in sort of premium luxury, but in non-premium, some of these vehicles are coming to market at very, very low cost. We've seen significant growth in Europe, so great adoption in Europe. That's been mainly driven by taxation. So it's become quite punitive to drive an ICE vehicle in many countries in Europe. France is a very good example, where the additional cost to our vehicles is very significant because of the tax that those governments have put on ICE. We've seen premium go much quicker as well. So we expect that around 80% of premium vehicles will be battery electric by around 2030. And some of that drive towards premium adoption is these vehicles are more expensive, but in the premium luxury space, there is more affluence and more affordability for those vehicles. We're also seeing plug-in hybrids doing very well in markets like the UK and also across Europe. But we've also seen that increase in preference for BEVs, and you've got some data coming on the screen where you'll see that shortly, that actually lots of people actually now wanting to start to move to a battery electric vehicle. And in terms of our competition, we're seeing now that there are some manufacturers who have already made their last larger SUV vehicles. So in segments SUV 4 and 5, the territory which a lot of our vehicles come into, the last of some of our competitors have now produced them. So no more of those ICE vehicles coming.
Okay, thank you. And in particular, why are people making the change?
Yeah, so we do lots of research in this space. We have done since many years before iPace came to market. There are a number of reasons, and some of them affect different consumers in different parts of the world in different ways, but some people are purely driven by the desire to be green. Any of you in the room with children will probably notice a lot of pester power and pressure from your children on many things. They're kind of trained in schools these days around sustainability. You know, you've got green schools, and you know there is a lot of pressure from both younger and older children for parents to go green. So for some people, environmental benefits are a big driver. For others, and this is quite pertinent in our part of the market, just having the latest, greatest, you know, coolest tech, and that's what electric vehicles are, is a big driver. We see some people motivated by the fact that they are cheaper to run. So getting great energy tariffs, being able to charge the vehicles overnight and take advantage of that. There's lots of subsidies historically around, so we've seen markets go very quickly where governments have subsidised and people have had great benefit. There's been lots of access benefits. It's almost a bit of a sort of smug factor for some of our some customers, where I can drive in lanes where other people can't drive. I can park where other people can't park. I can get into cities, so cities now actively banning internal combustion engine vehicles. Some are driven by the convenience, so once you get into the habit of driving an electric vehicle, being able to just plug it in overnight, have it charged the next day, never have to go to a petrol station again, is a big motivator. And then for others, the drive experience, these vehicles, the acceleration, it's a bit like being on a roller coaster. If you accelerate hard, they do throw you back in the vehicle. Some people are really attracted by the quietness of them. And for others, the promise of autonomy. So Tesla came to market in the early days and started to make the vehicles autonomous, and that's a big driver as well.
Okay, thank you. And on the flip side, what are some of the barriers that are preventing some of our customer bases taking up on the BEVs?
Yeah, and there are still barriers that we have to help customers to overcome. We lobby a lot. Governments around the world also do this. But, you know, some people are worried about the range. Ranges are improving quite significantly, but everyone sort of plans for that really big, long journey, the once a year when I might drive for some of our customers to the holiday home or to see distant relatives. So that's always a bit of a concern for people. Charging, people worry about wasting time, particularly again on long journeys, that they've got to then take a longer break than they would if they were just refueling the vehicle. Costs can be a barrier, so these vehicles are more expensive, so that's a consideration. You've got to pay to install a charger. For some people that can be a barrier. In some parts of the world, and this is quite prevalent in China, they're a bit worried about battery safety. Of course, whenever there is a problem, it hits the press quite dramatically, and that can be a bit of a scare factor for some people. For some, the uncertainty of how reliable are they. You know, we've had ICE vehicles for, you know, ever and a day. Will these vehicles be reliable? For some people, if there's a model that they particularly like, and we've been in this space, only really having had one fully electric vehicle, actually I want a Range Rover or I want a Discovery, we haven't made them as an electric vehicle yet, and therefore people aren't prepared to compromise. Some people are worried about the battery life and the cost then, associated cost after that. And then finally, you know, there is a question mark for some consumers as to whether EV is really as sustainable as we, you know, or others say it is. So quite a few questions. Obviously, our job in the marketing and commercial team is to, you know, talk to consumers and to educate and to, you know, make sure that we can convince and persuade and to distill some of these barriers.
Okay, thank you. This is the last one now. How are we ensuring that our BEVs we are developing meet our customer demands?
Yeah, we do a lot of research. So I mentioned that we'd researched I-PACE from the very beginning. Every battery electric vehicle, every plug-in hybrid vehicle, we do extensive research. So usually around 6 years out, we'll start thinking about the needs of the target audience for the vehicle. We'll research all the way up to the vehicle being locked down and no further change. At that point, we make sure we have enough insight to inform the communication of the vehicle. So how should we bring it to market? What should its positioning be? And then once vehicles are in market, we, as soon as we possibly can, start speaking to the early buyers and the rejectors of the vehicles. And we use that learning to then inform model year updates, mid-cycle refreshes, and then future generations of vehicles.
Okay, thank you very much, Joe. Thank you very much indeed. Now I'm going to move over to Stefan and ask you a few pointy questions about our fantastic EDUs. So, Stefan, an EDU, what is it?
Yeah, it's probably the most fun in the car later on, yeah? It's that unit that produces the torque and the power. And when you see electric cars today, they are beating the competition by far. If you have an ICE car versus a battery electric car, the electric car always out-accelerates it because it has the power and the torque instantaneously. And the whole characteristic is you have torque at the beginning, and then it starts to go into field weakening and gets a bit slower. But you have that when you're at the red traffic light. So I think EDU produces all the torque and power and is there for the most fun. I think we have a video to introduce it, Stuart. Yeah, as you can see, it looks very easy, doesn't it? But as usual, it's hard. And what does it do? Well, you see what it does. We have one in the front, one in the rear. It produces all the torque, all the power. And another thing that's very important to understand, it has three major elements to it. So one is the e-motor, which I think we can be very proud of to produce this here to a level that glue and paper and wire comes in, and we do a hairpin, and we put the whole thing together here. We will have, of course, an inverter that we have from a very competitive company from China coming in, but don't worry, the chips are all from the United States, so it's a very global project. And we have the latest generation of high voltage chips on them, and the most refined on them. And then, last but not least, we have all the mechatronics, which is the lubrication, which is the pump, which is the gear set, to transform the power into the right level of speed for the vehicle. Yeah, needless to say, what is so special about them? And as Stuart already said, everybody has them in a way when you have a battery electric car, but what's so special about the ones that we do at JLR? I think we can say without any wrong words or not trying to brag anything here, these are the most advanced ones. So it's not that we have the best chips or that we have the best sheet metal for the steel laminations or that we have the best possible overall concept for these cars. It's also that we have filed for the company over 200 patents. And 82 of them are in a serious stage that we can say they will be likely granted. And this is a hidden IP, isn't it?
Yep.
Imagine 82 patents, and we have them granted for us. What that means in terms of securing for JLR a space where others only can go if they pay money to us. And that's quite a comfortable situation to be in.
Okay, thank you, Stefan. And there's a lot of discussion about the rare earth materials used in EVs. How does this impact JLR?
No, that's a very good question. Rare earth materials are mainly known as magnets, yeah, and there's heavy rare earth materials, which are particularly the ones that are critical for e-machines. It's called dysprosium, it's called neodymium. Those materials are in high demand. They are, funny enough, very easily available in China because they have open mines, they have very easy access to these resources, while in other parts of the world you have to drill down very deep. It's much more difficult to extract that from mines. And China has a monopoly on them, let's face it, yeah? And not only that, they also have a monopoly on it in terms of producing them. There's a lot of refinement going into this. To make a little magnet, you have to think about 2 weeks of production time. It's something that's not well understood, I think, in our world, because China dominates that space. But rare earth materials, having them and refining them and bringing to the market, China has the full control over it. Therefore, rare earth materials are a little bit difficult for us because we might end up in a position that somebody dictates us what that costs. Needless to say, it's only a portion of the car. So even if you take a combustion car today, all the electric seat, all the loudspeakers, all your PCBs for your navigation system, your mobile phones that you carry around with you, they all have these materials in them. So long term, we thought we're going to do 2 things. So the first thing is we're going to use only half of our motors with rare earth materials. So we have a mixed motor concept. Front axles on all our cars are rare earth free. They're induction motors. The one that does do all the main job for efficiency, they got a lot of magnets in the back. But I think we're already by then only half exposed as our major competitors, which is a good thing. That's a good cost control. That saves us from any scrounging that might be happening geopolitically there. And let's face it, if we would be in a real bad position, we could switch over to induction motors completely. The car's still very powerful. It's not as efficient. You would lose a lot of range. We're talking about 20 miles of range, so yeah, you want to have 20 miles of range extra. That's why we say rare earth materials make a lot of sense. But it puts you also on the second step where you want to go and say, we would like to extract all these materials. Because when we would do the mining in this factory here, and I would collect all of your mobile phones, I could produce a couple of motors with that. And I think this is where we need to go, that we take all these magnets and extract them again and come into recyclability. And then we do not have to worry about the geopolitical elements of it. And Stuart knows I'm very passionate about all the sustainability. I brought another example, not just rare earth. I brought something in here, which would be now the doctor's place. You would think this is not so nice, but this is oil. Yeah? And the oil that we have here, this is iPace, and iPace has been only designed for lubrication. So this is a nice oil. It sticks to the gears, sticks to the bearings, and the whole thing is lubricated well. It's a bit less viscous than what we put in the engines today. Hence, it did the job, and all I-Pace drivers are using this today. When we moved on with our design, we said, let's have a look again at cooling and lubrication, and couldn't that be one thing? So this here is a coolant and a lubrication, and it's, as you can see, much more viscous. It's almost like water. This helps us with the efficiency, because all the losses that you have with the transmission, they're minimized that way, and this gives you an extra level of range. If you put this in our drive units versus this, we're talking about 3 miles. So it's quite a big impact that this low viscosity oil has. So far, we think it's the lowest viscosity oil in the market, so it's very special. And it also does the cooling job for us, which is also very special, because you cool an e-motor, it has to have low sulfur content. If you have this in a transmission, you want to have high sulfur content. So you have to balance this really out to have both functions possible with one. And now the best story is, in the engines behind us, we fill engine oil today. And that engine oil, when it comes for the first service, will be extracted from these engines. We will take that oil and we recycle it and make this out of it. And therefore, we're the first ones having a sustainable oil in an electric drive unit. And I really hope we're going to be very communicative about it and tell everybody that we're the first ones doing that, because everybody else, they're still taking fossil oil that's been freshly made for them, while we're using this as a recycled oil from our old engines.
Yep, fantastic. Thank you, Stefan. And we'd have seen on the slides previously, we know our EDUs are going to go into our future JLR brands. Are there any other news of our EDUs being used elsewhere within the organisation?
I think we can proudly say that there's somebody in India, our owner technically, Tata Motors, who was scanning the market for the last 2 years. What is their next electrification thing? And they could have picked anybody. They could have picked anybody that meets their cost requirements, etc. But they came eventually back to JLR and said, we're going to take you. So the Avinya platform that Tata Motors has announced is basically our compact EDU. It's basically our backup. Yeah? It's basically our car. So we can be priding ourselves that we have, with somebody neutral scanning the global market for what's the best value for money technology, that they have picked us. And that's why it's always so important that we not only do high tech and create IP for us that protects us from the competition, that we always have an eye on what's the cost. And I think we've been very successful at that when Tata comes back and tells us we pick you.
Okay. And lastly, Stefan, just here at the Wolverhampton, we're going to build our EPMs, our EDUs. Are there any other OEMs doing that within the UK market?
Yeah, that's interesting that in the UK we're going to be the biggest operation. So this place here can pride itself, hopefully in a 2-3 year time frame, yeah, when it's all up and running and we have all the productions ready. This is the biggest EDU production and biggest e-machine production site in the UK. And therefore we're leading the field in this place. And I think we can also say very proudly, we have one of the most modern facilities to do that. And we have the best equipment. So everything that Stuart, you and your team have been organizing, be it the grob line for the stators or be it the ThyssenKrupp for the assembly, this is all top notch. So the equipment that we will have here, we will have people come and visit us, I'm pretty sure.
Okay, fantastic, Stefan. You mentioned a word there, proud, and it really is, so thank you very much indeed. Okay, Parmjeet, welcome again. Can you tell us a little bit about our batteries?
Yeah, so I think we've got a video shortly, but our batteries, so when we started designing our batteries, we did all of the usual things. So we looked at the competition, we looked at how they were designing their battery packs, and we also had some experience clearly from I-Pace, and then more recently our in-house PHEV battery. And one of the things that we quickly realized that actually, in order to be able to maximize the amount of energy that you can put within a battery pack, there's really only 2 dimensions that you can grow. So you can either have very tall batteries or use the width of the car and fill the width of the car with the energy, so with the battery cells. A lot of our competition have gone for height. So if you look at a lot of our competition, so some of the BMWs, some of the Audis, they're very tall, very big cars. And actually, some of our EMA products, we want to be really to stand out from the crowd and not necessarily have those attributes. So what we did is we set about really looking at the cell, so the actual energy that houses the energy that's going to propel the EDUs and propel the vehicle forward. And what we've come up with is essentially a unique battery cell concept, which essentially allows all of the connections to be on the side of the cells rather than on the top of the cells. What that allows us to do is it means that we can control the height of the battery to make it as thin as possible, but by maximizing the total room that's in the car to put the energy and therefore range for the customer.
Okay, just looking at the video, Parmjeet, aren't all batteries the same then?
So I would say that the element that makes up the cell, so the energy, essentially they are the same. However, it really depends how the cell is packaged. So some of the things that we can maybe connect with on a day-to-day basis. So if we look at our mobile phones have what we call a pouch battery, which essentially is a battery with all of the energy storage material laid out flat, almost like a piece of paper. Now, what you can do is you can stack those together, so as multiple, almost like multiple pieces of paper, and that's called a prismatic, which is essentially is what we're using. But in order to be able to control the battery, you need to then be able to put that in a housing, in a casing. So if any of you have got children and they've got an electric car, the battery that's in that electric car is a prismatic battery. And you may also be able to see them in alarm boxes as well, so as a backup battery, so it's the rectangular batteries. And then the final format that you can have is effectively by taking that, let's say what we call the energy, so that piece of paper, and rolling it up. And that's what we normally use, majority in the domestic use, is what we call cylindrical, so your AA and your AA and AAA batteries. So those are the three formats. So essentially the constituent parts are the same. However, what makes them differentiate between each other is how we create the chemistry that goes in the cells. So what you can do is you can make a cell that's really good for longevity. You can make a cell that's really good for being able to manage temperature, so being able to operate at low temperatures like our vehicles do. And you can also have batteries like the ones in our mobile phones that have a life. They have a 3 to 4 year life, and then after that, we've all seen our battery life on our mobile phones drop below 75% after a few years. Now you can influence that by the way in which you create and mix the chemistry. And then the next stage, really, as you saw from the video, is really how you put the batteries together. Now, one of the unique things that we've done on our batteries is we have the side terminals. We weld those side terminals. So Tesla, for example, don't do that. And the reason they don't do that is because their design doesn't allow them to do it. Now, by us being able to weld those terminals to be able to connect all of those cells together, if we look at our manufacturing process, it's much more reliable, much more efficient, and actually, ultimately, the amount of what we call energy density, so how much energy can you get into a space, is much higher. So they are ever so slightly different, but there's some choices you can make.
Okay, thanks, Parmjeet. And just bringing this back into JLR, so obviously iPace is renowned worldwide. How is our future BEVs going to be different, or is it the same to iPace today?
Yeah, so I guess to start with, we've got a very different construction compared to iPace. So if we think about iPace, you've got a cell, you join those cells together, you put those cells in a box, which essentially is a module, and those modules you then put in effectively another box, which is the battery casing. And then you join all of those modules together to get your full battery. Now that's a concept that that was very widespread in the market at the time, and we were the first to have done that with iPace. However, again, there's a few choices you can make around the battery design, and the choice that we've made is to have what we call a cell to pack. So we've actually removed completely the module. And what that means is, as you saw in the video, and we've got on the screen there, the way that the stack, so what we're calling the stack rather than a module, the way that that's constructed, and I've got a few bits on the desk here, is you start off with an end plate, and then you place the cell spacer. So you put the cell spacer next to the end plate. You then put the cell next to that, and then another spacer, and you keep going until you've got the length of the stack that you require. Now, for our 3 platforms, so MLA, EMA, and JEA, for those 3 platforms, that essential design stack is the same. It's exactly the same. It's just different lengths. So what we then do is we then have to connect all of the different cells together. So we've got a carrier for all the bus bars. And then more importantly is this thing here, which essentially is the cooling plate. And the cooling plate has got an extremely important job to do. So it does 2 jobs. The first job is it obviously cools the battery to keep it at an optimal level, to make sure that the cells are kept in the best condition. And the second thing it can do, and particularly with the capability of our vehicles, is it can actually heat the battery up. And that's really essential when you're trying to start the car at -40. And a couple of months ago, we went out to Sweden with our first prototype vehicles, and we had absolute brilliant success. We were able to operate our vehicles at the -40, and those were some of the initial prototypes. Now, if we look at iPace and what's the difference with that design concept compared to iPace, so if we look at the capacity within the battery compared to iPace, it's around 43% of an increase in energy. We've got around a 92% increase in vehicle range. And if we look at charge time, it's 3 times better than iPace. That's phenomenal. Absolutely phenomenal. And that's really thanks to the innovative design of cell to pack and the construction of our stacks.
Some great updates from the guests in terms of the why, the technologies themselves, but one for us, Stu, what's next for us as EPMC?
Okay, yeah, thanks, Matt. If we just move on a little bit. So those may or may not have seen this slide before. It's been used quite in quite a lot of forums. You may have seen it last year where we talked about the journey here at EPMC, and where we are at the moment is obviously between the second and third picture in, as Matt alluded to earlier on. We're just about to finish installing all of our equipment here at EPMC for phase 1. But that only gets us up to 150,000 batteries and 278,000 EDUs. Next step, between between this year now, we will stop the rest of the machine hall over in Module 1. So you will have known that the headline has already ceased, and the next step is to bring to a controlled stop the crank line in Module 1 and the cylinder block line as well in Module 1. That's pivotal really for us in the plant to look forward. And Mark touched on it earlier on that we're using our full JLR enterprise by utilising CJLR to bring in those components, and our fantastic team here in Module 4. That's allowing us to then install the next level of capacity for the plant. We will go to a capacity of 300,000 batteries and 555,000 EDUs. For those good with the maths, we're only producing the front EDU for Jaguar, that's why it isn't double. But we're not stopping there. That's going to take us really up until 2025, 26. But we know that Joe's already talking about, we will see a decline and a cessation of our 4-cylinder production as well. So at the moment, we're looking throughout this year of what is next for the 4-cylinder assembly area, as that comes to controlled stop in the back end of 2027, 28. But then the last slide on the right, under Mark's leadership, you know, we are really looking now at the transformation of what is our want to be, what's our North Star post all of that activity, post 2035, when, as Joe alluded to, when full ICE production ceases. Over the next 12 months, we want to be really, really locking that down on what is our want to be. For me, it's really exciting, really exciting period of time. Hopefully, from an ENPS point of view, bit of a prompt there from Hannah earlier on. Please talk to us, you know, talk to your leadership group, answer the surveys, put in the verbatims. It's really pivotal that we're all part of this journey, yeah, because it's absolutely exciting and really thrilling to be part of. So, yeah, fantastic.
So, now you've heard from the panel of guests, from Stu, from myself and Mark initially. We've got the opportunity to open up for any questions that some of the audience may have that may want to put forward to the group. I think we've got a roaming mic somewhere.
Hi. Thanks very much for the explanation to start with. Really, really good to understand the detail and the level you've gone into. So really appreciate you coming and giving us that today. I've got a question regarding where we go next. We can see that there's collaborations going on with other manufacturers in Japan, for example, where they're combining together. They want to be at the forefront. We look like we're there. How are we going to stay there? And I suppose my question is to Joe, what is coming next? Have we got insight of what that is? And how are we going to remain there as JLR? Because it's a fantastic product now, but we really want to stay there for our future.
Thank you. Yeah, thanks for the question. So, I mean, we have a full portfolio of electric vehicles coming. So every product in our lineup today on Range Rover, in the Discovery space we're working on, within Jaguar, replacing our portfolio, everything is being electrified, and you know, all of that we research really heavily to make sure that we can meet and delight customers as we bring the products to market, but we're constantly researching them to make sure that every model year update, every mid-cycle refresh, that actually we're bringing more to the vehicles so we can stay ahead. So yeah, that's how, from a broader product perspective and product features, we work.
Have we got any other questions across the group?
Just a quick one. I've watched a lot of this on YouTube as well as other stuff. A lot of big companies are actually slowing down their production of electric cars. So I see on the telly. And second-hand, they seem to have a problem selling them. I just wondered if that's true or not. You know, VW have cut back, GM have cut back, Ford are cutting back. They're not producing as many electric cars. So is that the future or not?
Should I take that?
Do you want to take that, Joe?
Yeah, happily. I mean, it's not an exact science in terms of you take lots of sources for, you know, how quickly will the market grow, how quickly will consumers adopt, how will the legislation change. We've always been slightly behind in our forecasts, and we've seen the market grow at a faster rate than we were predicting. Arguably, we're a little bit late bringing some of our electric vehicles to market because there are quite a few out there already. So we, in a way, can't wait to get them into market. I think in the last probably 6 months or so, we're seeing some signs of that growth slowing, but there is still enormous growth. The legislation is still in place, and there is still a very strong move to electric. We're very excited to be bringing the Range Rover and Range Rover Sport battery electric vehicles to market very soon. The demand that we've had for those vehicles has been phenomenal. So we opened the order books, thousands of orders coming in very quickly, people wanting to be kept informed, wanting to be the first to get them. So I think for us, we're not one of the biggest players. Actually, the level of demand that we foresee, we can meet and more. Our order books are incredibly full right now, and we see that they will continue to be for our electric vehicles. We're also using the opportunity to create electric vehicles to make sure that we can fully optimize those vehicles so they afford us more space in vehicles. So products where customers might have wanted more space in the past, so Evoque is a good example. Redeveloping that vehicle as a fully electric vehicle means that we can reduce some of those compromises that perhaps we've made in the past. So it's an exciting opportunity, and the demand certainly is there. I think what you hear is perhaps a little bit of slowing, but it's still growing at a considerable rate.
And it might not be widely known, but within the marketplace, you either have a BEV or a PHEV stroke ICE variant. The Range Rover and Range Rover Sport will be the only vehicle you can go into the dealership, and then when you're going through the check, it is the exact same car, but do I want an engine, a fantastic engine that we produce here? Do we want a PHEV combined with our friends and colleagues at BAC, or do we want a BEV? So that will be the only vehicle line out there in the whole of the premium sector that you will be able to have that opportunity. So again, it's that flexibility that it's offering as well, our customer brand.
We've got another question up the front. If you can have the mic.
Hi, thank you. So yeah, just to echo Richard's comments, really exciting to hear about some of the new products that are coming to the EPMC. So just a thank you to the panel for sharing that. My question is more about some of the challenges that we might be facing. So do you think that we're ready in terms of the infrastructure for sort of electric charge points to bring electric cars to the market?
Very, very good question. Who would like to take that one?
So I can try to answer that. So I think if we look at the infrastructure, particularly in this country, as well as around the world, I think it's clear that it's developing. The infrastructure has got better and better as the years have gone by, and people have started adopting, say, PHEVs rather than full BEVs. But if you look at the motivation particularly from the UK government, they absolutely have a very, very clear ambition to improve and increase the the infrastructure for charging. And not only that, is roadside charging as well. So for people that don't have a driveway or need to be able to charge by the side of the road, is to convert some of things like lampposts and things like that to allow for charging. So they're really looking at different innovative ways of being able to put the infrastructure there. If we look at rest of world are very much probably further advanced compared to where we are here in this country in terms of in charging infrastructure, and particularly where some of the markets are developing into the EV space, so things like China, things like India, Russia, some of those countries are really pushing ahead massively because they don't necessarily have the same burden of previous infrastructure. In some cases, they're having to put infrastructure in brand new, and they're opting to put in charging infrastructure. Yeah, and even things like fuel stations are no longer; they are charging stations. So it's very mixed. It's a very mixed position around the world, and I think we'll see in the next few years that it will just continue to grow.
Parmji didn't say that, but he can charge with 350 kilowatt. That's world record. And you can also charge at 150 kilowatts on those slower charges, which is also world record. Yeah. So in a sense, we have a product that actually can cope with fast charging and can make usage out of those fast chargers, which a lot of our cars today, they cannot. But I think it comes down to one very important point: what's the cost of that overall thing? We are having very expensive cars, so we are blessed. It doesn't make any sense to buy our cars from a financial perspective, doesn't it? But we still can sell them. And that's why we're a bit more protected, and answering hopefully your question a bit, why we are not so much in trouble like Ford. Because we don't sell over the price, we sell over a desirable car. And we have the tech also to command that high price in it. And needless to say, we are in a position where the whole market has seen the China shock. And yeah, you probably know better than anybody else, Joe, that the Chinese have heavily subsidized that sector, and you can get fantastic electric cars for half price. Give you an example. Volkswagen's ID3 in China costs £15,000. You wonder why does it cost 35 here? So China has heavily, heavily subsidized these prices and undercut everybody, and that's the China shock that those companies are having. And we will see, short or long, also the drop of that. And the adoption rate that you're referring to has to do with what? What's the cost? If you go to the dealership, as Stuart has said, and you can make your cross at the cheapest option, and that's then maybe the most environmentally friendly and the most performant one, then everybody will pick it anyways. And we will see in the next 10 years, because of all the installation, we're not the only one investing, a lot of people investing. With all this installation, the cost will come down, and there will be a parity point where all of a sudden, the BEV is the one that you can afford the easiest way. And then people will forget about charging an hour, because it's the cheapest, the same as they did with diesel. They did accept diesel. It was stinky, it was loud, it wouldn't start. Not everybody had diesel fuel, go all the way back, but it was cheaper. And everybody bought a diesel since. And BEV will probably go through a similar story.
Just a quick one. So we've heard about like the cooling unit on top of the battery packs that can either cool it down or heat it up depending on where you are and what the temperature is. I was just wondering if there's any other safety elements that we're looking at to stop incidents like the Luton Airport incident with the battery that overheated and then we struggled to put it out. What are we doing to make sure that that doesn't happen in our cars?
That's, may I say one for the Luton Airport? That was a diesel Range Rover. You fell for the first typical angst that the media has portrayed. But we have studied the case. It was a diesel Range Rover. So just make sure the Luton wasn't a battery incident, but Parmji.
Yeah. So there's a couple of other measures. So if we look at conventional, traditional batteries, they use traditional coolant. Yeah. So they use the normal coolant that you have in your engine. And we've actually moved to a slightly different coolant solution on our BEVs, which essentially is it doesn't allow for short circuits. So you can completely immerse the battery in the coolant, and you won't get a short circuit. Now, so that's let's say on a physical side. The other side is we've also got some other innovative technology within the battery pack, which is when we talked earlier about the stacks. At the end of each stack, you've got a piece of electronics, and that electronics measures things like temperature, constantly measures temperature, constantly measures voltage. And that piece of electronics is completely wireless. So that's completely wireless, so it has a wireless connection to essentially the battery control module. So that's the brains of the battery. And what that will allow the battery pack to do is if it detects that it's getting too hot, or it detects that the cells are not behaving themselves, let's call it, it's able to start communicating with the stacks and start to apply things like cooling and heating to those cells. So I think fundamentally through the inherent design that we've gone to, where we've got a stack design, we've got the wireless, what we call CSCs, and also we've got the coolant that is electrically, or it's dielectric coolant, so it's electrically isolating. With all of these measures on top of each other, we've demonstrated both from a legislative point of view, but also from some of our corporate tests, that we can instigate a short circuit within the battery pack, and the battery pack is fully able and capable to demonstrate that that event is benign, essentially.
Hello. Hi. So, as you mentioned, we're a bit slow to market, weren't we, with electrification? My question is, are we looking at other forms of propulsion? Because I can see from our competitors, they're looking into hydrogen. And obviously, you've got cost issues with magnets, as you mentioned. So is it worthwhile exploring those avenues as well?
Yeah, I mean, we see hydrogen development really for mainly industrial uses today, and really not much demand. So we research every year to understand fuel type preferences from customers. At the moment, even by 2029, our expectation is that the level of demand for hydrogen is less than 1%, whereas we will see BEVs hit nearly 40% at that point in time. There is some investment into hydrogen, but nowhere near the levels of investment going into battery electric vehicles. So we're monitoring it, but at the moment we just don't see either the consumer demand or the development beyond industrial solutions for use of hydrogen.
So, do we have any more? Anybody else? Mark, how can we say not?
Yeah, I have a question. I think you mentioned, Bajir, the cold test mission that took place some weeks ago in the north of Europe, and it was fantastic. I think Rob Penford attended this event, and his words when he came back were, I think, just fantastic. Maybe you can, or Stefan, share a bit of his emotion and passion about that as well?
Oh yeah, thank you, Mark. That's a wonderful question to answer. Everybody who had the chance to drive one up in Sweden said it's the best Range Rover they've ever driven. It's the easiest to drive, it's the quietest to drive, it's the fastest to drive, it's the most controlled to drive. I think we haven't mentioned that much yet, but one of the patents that we have put forward is we can smell the snow with the e-motor. So we call it integrated traction management. And what it does is the field gets controlled by the inverter. And you see quickly whether this is now spinning too fast or not. That tells you whether you're on snow, on ice, or on a normal road where it would go slower up. And then it can react quickly and just derate it. You do this today in a normal combustion car. This is a long circuit of information that needs to go. You first need to detect that your wheel is spinning. Then you need to put the ABS in and brake it. And then you need to put also a signal to the engine to get the torque down. This takes quite a bit of time. It's a safe thing, but is not as good as you directly smell the snow and ice on the e-motor, and you control wherever you go automatically without having the wheel actually breaking loose on the surface. It's much more attached to the ground. And everybody was blown away by that performance, by the grip, by all the compulsory that the car has. And it is a blast. It definitely is a blast.
I think we had a question up at the far end.
Yeah, I'd like to thank the panel for their time and sharing their valuable information. Just a question from me around sustainability and looking forward into the future. Are we looking at recycling batteries and packs? And if so, where are we on that journey?
Okay. So there's two elements to it. So one is being able to essentially repair. So that's the first element. So we've designed the battery packs such that they can be repaired. So if there is an issue with the electronics, for example, or the stacks, you can remove them and replace them to renew that battery to its prior state. The second thing that we're doing, particularly with Agratus, which is the collaboration with Tata for cell manufacture, is to really look at how we create a complete ecosystem. So how do we create a complete ecosystem from mining the raw materials to processing the raw materials to manufacturing those into cells to then manufacturing those into battery packs, and then the recyclability of that back into that entire cycle again. And so we're studying that at the moment with, in collaboration with Agratus to see how we can organize that and set that up such that we can create that ecosystem, which ultimately is going to benefit us here in the UK, whereby we won't necessarily have to ship precious materials in from different countries to assemble into cells.
Yeah, we're going to be installing a lot of new technologies. We're all used to building engines, but not so much batteries and EDUs. Just wondering, what are we doing to prepare ourselves for those new technologies?
I think. Well, you know, we've touched on it this morning, but just put some pound signs to it. Over £800 million of investment into the plant for all our new technologies. Circa 500 new employees across the whole of the plant when you look at our key suppliers, LeadEc, etc., our marketplace and our associates, our sales and staff. From a training point of view, Matt's already touched on 650 hours so far this morning, and the immersion events. We've got circa 60 employees in Lions Park today that are embedded in Lions Park getting the training. Sorry, Dean, the grind is kind of throwing me now, but yeah, so from a training and a plant readiness point of view, we have our weekly Gemba reviews chaired by Mark, where we're walking around as well, really looking at the KPIs for the readiness of our workforce and also the equipment. We've got all of the training in place. We've got our critical roles that are hired now. And really, we're part of a fantastic journey now, and we're just kicking off. So, and kicking off in a positive way. You know, it's fantastic to be a part of, and the training and all our associate readiness is absolutely critical where we are in the readiness now. We've got the facilities bolted down, and as we commission those facilities, all of the training and 3 quadrants, etc., that is going on in parallel now so that we are match fit and ready for July when we start creating our EDUs and batteries. July this year, everyone. Yeah, it's coming quick, and it's coming, yeah, really good.
Do we have any more across the room?
On the earlier slide, it says, in the future, every car's got to be able to do 100,000 miles or 8 years. And we're all going electric because we all want to go green. What do we do with the car after 8 years? Do we replace the battery or do we replace the whole car?
So the battery, so there's a couple of different measures. So from a legislative point of view, the battery needs to have 75% of its capability essentially at the end of its life. Yeah. Now, whilst from a warranty perspective, it's 8 years, but actually what we're engineering to is more like 10, 12 years. So through some of our work that we've done already, which is currently still in progress, but will be completed fairly soon, we will get nowhere near 75%. We will be way above that. So the capacity of the battery will be very easily capable of achieving 10 years capacity of greater than 75% state of charge. So that's the work that we've already done, and we're going to continue doing that. We're now on to the second round, so we're trying to prove it to ourselves a second time, not just waiting for only one result. So I think if we look at the longevity of the vehicle won't be compromised just because it's got a battery energy storage in it and an EDU. It will be as capable as ICE engines.
No more questions? Right, okay. Well, thank you very much, panel, for answering those, and Stu as well. It's appreciated. So I think then, just moving on, I think Mark's going to rejoin us just to close.
Yes, this is my duty now. I won't enjoy one of these chairs, unfortunately. They look very comfortable.
Yeah.
Thank you. Thank you all for your expertise. I've learned a lot today. I hope you did as well. About the market, the complexity of this market, from some geopolitical aspects up to what our customers are expecting. I've learned a lot about our products as well, especially this oil. Thank you for that. It was a scoop to me. But also about the batteries. I mean, the product is just fantastic. And the cooling plate, which is also able to heat, is something new to me today. So thank you for that. Thank you for your great expertise. It was absolutely fantastic to have you all today. Thank you for your questions. They were absolutely relevant, and it demonstrates that you're already very well aware of what EDU is, what a battery pack is. So I think you are ready for what's coming next. And what's coming next is just fantastic. It will be our responsibility now to deliver these fantastic products for our customers. And it's coming very soon, as you said, Stuart. It's July, so in a couple of months. So really a big thanks to all of you today. I hope you feel as energized as I am for this great challenge. What we are going to do is just to write a piece of history for Jaguar Land Rover. So this is just, wow, this is just fantastic. And I'm sure we can make it with all of you. Thank you. Wish you a nice day and see you very soon. Bye-bye.